All right, let's take a look. And, we just checked. The main problem is not really checking. The main problem is how'd they do it, all right? And certainly we have some techniques that we've used before, use substitution. That's an important technique, and it does work. It's not going to work in that one. But we have another technique, and the other technique we have is called integration by parts, and it uses the product rule. Well, if you recall, in my checking, I used a product rule. I'm going to call it product rule relatively simple. Right, might be writing a little foreign way to you, but using V's, you can do that. The derivative with respect to x of the product of u and v, where you understand that u is a function of x, and v is a function of x as well, whatever that is, all right? So you differentiate it, and it's not bad to differentiate that. It's something we've done before many times. Let me get my eraser out, keep doing that. All right, so we're going to differentiate that, and then relatively simply using the product rule, you get this over here, and then we just rearrange the terms. In other words, I solve for this thing over here, relatively simple. Then what do? I integrate both sides. I take the antiderivative of both sides. That's all I do. And what's nice about that is it's, the antiderivative of this guy here is really simple. Right? Really simple. What's it going to be? It's going to be this over here. It's super simple. All right? So really what are you left off with? You're left off with, something which I'm not going to say is any better than what we had, but u v prime dx would be equal to uv. I'm going to forget about the constant because I got another integration which has another constant in it, and we'll talk about that later. Okay, the hope is this over here, that this guy here is tough, but this guy over here is easier. Right, that's a hope. It's a big hope, by the way. Sometimes it gets worse. However, sometimes it remains the same. It doesn't get any easier or more difficult, it just remains the same. Our goal is to get it to be easier or at least remain the same. We don't want to make things worse, all right? So the bottom line is we have to worry about this over here now. We're worried about that, all right? So the technique, I'm going to write a little differently. And the reason I write a little differently, all those symbols in there kind of, I'm not going to say confusing, but they can be confusing. So I make some observations over here. Whoops, sorry about that. And I'm just making a simple replacement over here. Right, that's all I'm doing, simple replacement. So this is just a simple replacement. Let me write down what I mean by that. If I'm going to do that, let me just do that replacement for you. So you would get u, and v prime dx is just dv, uv minus, well, I can do a commutation. U prime dx is going to be du. And then you get v. This is the most typical way it's written down. It's most typical. Right, most typical. I would recommend, if you're going to remember anything from what we discussed today, that you would remember this over here. This is really important, by the way. All right, really important. I'll write that next to it. This is important. Okay, if you have a definite integral, it's pretty easy to write that down as well. And what is it going to look like? Well, you're putting limits of integration over here. You're doing an evaluation is all you're doing, all right? Let me emphasize this again. This is the important part, right? This is the take-home message from this part of the lecture. Thank you.